All right, this is Chapter 4, Test Review on the calculator portion. We're continuing on the back page. Number 2, the graph of f consists of line segments shown here, f of t. So let g of x is equal to the definite integral from 2 to x of f of t dt. So really, f of t represents the derivative of g of x. Okay? However, we have to take note of the fact that g of x is defined as the definite integral of f of t. All right. Part A, find g prime and g double prime. We can simply use the rule that we know with second theorem of calculus to find the derivative of a function that involves an integral. We simply take the upper bound, plug in for our initial variable. So f of t turns into f of x times the upper bound's derivative, so times x prime. The derivative of x is simply 1. So g prime is simply f of x times 1, which is simply f of x. Right, and if I want to find g double prime, g prime will turn into g double prime if I find the derivative, and then f of x would have to do the same thing. F of x will turn into f prime of x. Right, these are all geometric shapes. We can go ahead and find the areas of these each of these regions. In fact, this graph is used from it's the same from the previous review page on the average value. So I use the same graph here, but this problem is used in a different context. So we find all the areas here. Any of these area that lies below the x-axis, we have to make sure we put a negative in front. These are all going to be negative values. And 1/2 base times height for all the triangles, and then for the squares, simply base times height. All right, so part C, find g of 4. So if we want to find g of 4, we use the rules that's given to us. So to find g of 4, we simply replace x with 4. So then we have the definite integral from 2 to 4 of f of t dt. So we simply look at the graph and we add up the areas. So from 2 to 4, this entire region sits above the axis. So we keep these as positive values. 1/2 plus 1 is simply 1.5, or 3/2. Part D, find g of negative 2. So plug negative 2 for the x. So we're trying to find the definite integral from 2 to negative 2 of f of t dt. Now we want to read the graph with the lower bound being the smaller value. So I'm going to switch the lower and upper bounds. So this will give me the definite integral from negative 2 to 2 of f of t dt, but I will have to pull a negative outside. Okay, so let's go back to the graph. From negative 2 to positive 2, we're going to see we have 1 plus 1/2 minus 1/2 minus 1/2. So 1 minus 1/2 gives us just 0.5. So this gets replaced with 0.5, but then there's also a negative in front, so we have to include that to give us h of negative 2 being negative 1/2. Find g double prime of negative 3.5. So if we look back at our rule, g double prime of x is equal to f prime of x. So g double prime of negative 3.5 is simply going to be f prime of negative 3.5. So since this graph is the f of x graph, f prime of negative 3.5 would simply ask you for the slope at that on that line, on this graph. So the slope at this point, negative 3.5, will be on this line here. So if we can identify two ordered pairs on this line, find the slope, then any point on this line segment will share the same slope. So I chose negative 4, negative 1, and negative 3, 0. And I simply found the slope here, negative 1 minus 0 over negative 4 minus negative 3. Negative 1 over negative 1, which is a positive 1. All right, part F. For what value of x is g increasing? So g is increasing. Think of this as a derivative graph. So anything below the x-axis represents negative slope. Anything above represents positive slope. So we can create our sign line first, critical points being at -3, 0, and 2. And the first region here, this is negative value, negative slope, positive slope, negative slope, and then positive slope. So once we translate that onto a sign line, we can simply read the sign line and say that g of x is increasing on the interval from -3 to 0, and then from 2 to 4, because g prime is greater than 0. Part G, for what value of x is g prime decreasing? So we go back to our sign line, g prime decreasing, this is asking for the slope of g prime falling. So slope of g prime is going to be decreasing in this interval from -1 to 1, okay, because g double prime is less than 0. Okay, part H, find the absolute extremum of g on the interval from -1 to 3. So if we want to find absolute max and absolute min on the closed interval, we can use extreme value theorem, which tells us that we're going to be testing endpoints and critical points. These are the only potential points where your absolute max and your absolute min can occur. So from -1 to 3, so between -1 and +3, we're going to be testing obviously -1, we're going to be testing +3, and testing the two critical points in between, 0 and 2. So g of -1, go back to the rule that we have of g of x, so replace x with -1. So the definite integral from 2 to -1, we want to rearrange this with a lower bound being the smaller value. So I'm going to flip the bounds, pull a negative on the outside, and then the rest we just look at the graph to find the value. So from -1 to 2, from -1 to +2, we just add up these values here. 1/2 minus 1/2 is 0, minus 1/2 is -1/2. So that's our value, -1/2. But remember, we pulled a negative outside, so the two negatives cancel out. We get a +1/2. Right? To find g of 0, replace the upper bound with 0, because that's what the definition tells us to do. Okay. Again, we want to flip because the lower bound has the higher value. So we flip, we get the definite integral from 0 to 2 of negative f of t dt. So again, we read the graph from 0 to 2. We're going to add these values, combine -1/2 minus 1/2, which is -1. So -1, but then we also have to include a negative in front. So two negatives gives us a positive. Okay. G of 2, from 2 to 2, we don't have any area to find, so simply going to be 0. Anytime your lower and upper bound is the same value, your definite integral will always be 0. G of 3, so upper bound gets replaced with 3 based off of the definition given to us. So from 2 to 3, we read the graph, simply going to be 1/2. Okay, so now we want to find the absolute max and absolute min. We just compare all the values that we found, 1/2, 1, 0, and 1/2. So our absolute maximum will be 1, which will occur at g of 0, and the absolute min is 0, which will occur at x equals 2. Okay, last problem here. The following table shows the size of an incoming wave headed towards the shore at a given moment. So distance from left of the wave, and the height of the wave at these specific distances. So part A, use trapezoidal sum with six subintervals indicated by the data to approximate the area of the face of the wave. So trapezoid, we can't use trapezoidal rule because all the widths in these subintervals have different values. So we have to find the areas of these trapezoids separately. And the formula for the area of a trapezoid is width over 2 times h sub 1 plus h sub 2. So here's our first interval between 0 and 7. So the distance between 0 and 7 is simply 7, so that's my width. 7 over 2 times these two heights, or at these specific x values, so 0 plus 5. Okay, so here we have the formula for the first trapezoid. Second trapezoid, we look at the second interval from 7 to 18. So 18 minus 7 is simply 11. So 11 is the width, so width over 2. And we add the two respective heights, 5 plus 13. Okay, the next one down, between 18 and 24 is the width of 6. 6 over 2 times 13 plus 26, and we go down the line. Between 24 and 36 is a width of 12, so 12 over 2, respective heights. Between 36 and 44 is a distance of 8, so 8 over 2, respective heights, 16 plus 7. And finally, between 44 and 53, width of 9 over 2, respective heights, 7 plus 0. And we plug all this in our calculator. We're going to get a total area of 609, and our unit of measurement is square feet. All right, part B. Estimate the depth integral of h of x from 0 to 53 using 3 middle rectangles. So now we want to split all these ordered pairs into 3 subintervals. So here's my first subinterval. Here's my second subinterval, and here's my third subinterval. Now to find the width, I'm going to look at the endpoints of each of these subinterval and just subtract these values. So 18 minus 0 will be the width of my first rectangle. So that's 18. Times, now I want to use the middle height. So I don't want to use 0, I don't want to use 13, I want to use the height from x equals 7, which is 5. So that'll be the height of my first rectangle. So 18 times h of 7, which is 18 times 5. Okay, the second subinterval between 18 and 36, 18 minus 36 is simply 18, so that's my width. My height, I'm going to choose the middle y values. The middle y value, which will be 26. 18 times 26. And finally, the third subinterval between 36 and 43, I subtract those two values. 53 minus 36 is simply 17. And 17 is the width. The height, I want to choose the middle height, which is 7. So 17 times 7. Multiply and add all these together. We're going to get 677 square feet. Part C. Find the average height on the interval from 0 to 53 using the estimation from part B. So average value theorem says 1 over b minus a times the definite integral from 0 to 53 of h of x dx. And the approximation that we found from part B is 677. So 1 over 53 times 677 will give us 12.774 feet. And this will represent the estimated average height